Here's the video for week 5, day 1. I picked 4 example problems and then 3 practice problems, one of those being the attendance problem. Let's first look at problem 1. The directions are: calculate the distance between the 2 points C equals -8, and Q equals -1, -3. To solve this problem, we're going to use the distance formula. And I've written the distance formula here. So you can see we're given 2 points, C and Q. I label C by x1, y1, and Q I label by x2, y2. Then to find the distance between C and Q, we use this formula here. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So to find D for this problem, we just have to locate the coordinates x1, y1, x2, y2, and plug them into this formula. So we call C x1, y1, which means our x1 is the -8, and the y1 is the 0. Q is -1, -3, and accordingly we get the -1 is x2, and the -3 is the y2. So now we just plug these into the formula here. So we get D is equal to the square root of x2 minus x1 squared. This becomes a -1 minus -8 squared. Then plus a y2 minus y1 squared. That becomes a -3 minus 0 squared. And now we just simplify as much as we can. So we get inside the square roots. -1 minus -8 becomes a -1 plus 8. And this is all squared. Then this is plus -3 minus 0 is a -3, so we get a -3 squared. And now just simplifying even more, we get -1 plus 8 is a 7, so this is a 7 squared. -3 squared is a 9, so this is 7 squared plus 9. And one more step, or 2 more. 7 squared is a 49, so this is a 49 plus 9. And 49 plus 9 is a 58. So for our answer, we get the square root of 58. And you can check, but there is no way we can factor out a perfect square from 58. So this square root of 58 is the simplest form. So for our answer, we find the distance between the points is the square root of 58. Now let's look at problem number 2. Problem number 2 asks to find the midpoint of the line segment joining the points P equals 3 minus 8 and Q equals 7, 6. For this problem, we're going to use the midpoint formula, which I have listed here. So we're given a point P is x1, y1, so that's an x1 here. And the Q is x2, y2. And to find the midpoint of P and Q, we just apply this formula here. So M stands for midpoint. And it's going to be equal to x1 plus x2 over 2, y1 plus y2 over 2. So like problem 1, we just need to locate x1, y1 and x2, y2 and just plug them into the formula. So we can just match things up, and we have P is x1, y1, so our x1 is 3 and the y1 is a -8. The Q is x2, y2, so the x2 is a 7 and the y2 is a 6. So knowing these numbers, we just plug them into the formula. So we get for our formula for the midpoint, x1 plus x2 over 2 becomes 3 plus 7 over 2. And the y1 plus y2 over 2 becomes the -8 plus 6 over 2. And now we just simplify as much as we can. So taking the top or the left coordinate, 7 plus 3 is a 10, so we get 10 over 2. -8 plus 6 is a -2, so the second coordinate is a -2 over 2. And now just simplifying one more time, 10 over 2 is a 5. And minus 2 over 2 is just a minus 1. So our value for m, the midpoint, is the coordinate 5 minus 1. And so this gives us the answer. Let's move on to the next problem. Here's problem number 3. The directions are: find an equation of the circle that has center 6 minus 6 and passes through the point P equals 1 minus 2. So to solve these problems, we need to use the equation of a circle. And the equation of the circle has the following result. If we have a center HK and the radius R, then the equation of this circle with this center and radius can be given by this equation: x minus h squared plus y minus k squared equals r squared. So in order to get this equation, we need to locate the following. We need to find the values of h and k for the center, and we need to find the value of the radius r. First, we can find the center, because this is given. So just going along with this, the center is hk, so our value for h is going to be 6, and the value for k is going to be minus 6. Now we need to find the radius r. How do we find the radius r? Well, if you have some center here, we'll call C for center, and some point that it passes through, then the radius is simply the distance from this point to the center. So to find the radius, we will use the distance formula from the first problem between the point P and the center. So we can treat the h and the k like the x1 and the y1, and these can be treated as the x2 and the y2. So we just applied the distance formula between center and P. So instead of D, we're going to write down R. And it's going to be equal to the square root of x1 minus x2 squared. Here, h plays the role of x1. So that's 6 minus 1 squared. And plus y2 minus y1 squared. Here, k plays the role of y2. So it's minus 6 minus minus 2 squared. And now we just simplify as much as we can. 6 minus 1 is a 5, so this is a 5 squared. Minus 6 minus minus 2 becomes a minus 6 plus 2. And the minus 6 plus 2 is a minus 4, so this becomes a minus 4 squared. Simplifying one more time, or two more times, we get a 5 squared is a 25, and a 4 squared is 16. So this becomes the square root of 25 plus 16. And finally, we get the square root of 25 plus 16 becomes the square root of 41. But for our formula, we need r squared. So we can just use the r as square root of 41 and square it, and we get rid of the square root. So this gives us that r squared is just what's inside the square root, so that's 41. So now we have hk and r squared. We can just plug these into the formula down here and we're done. So we get x minus h squared, it becomes x minus 6 squared since h is 6. Then plus a y minus k squared becomes y minus minus 6 since k is a minus 6. So that is a y plus 6 since a minus minus is a plus. Squared equals r squared. And here above, we found r squared is 41. So this equal to 41. And so we now have the equation of this circle is x minus 6 squared plus y plus 6 squared is 41. Now I've chosen one more example for the equation of a circle. Let's look at this here. So our directions are to find the equation of the circle with center equals minus 6, 3, and diameter 4. So this problem is a little bit simpler than the problem number 3. We're still going to use the equation of the circle. So we need to know the center and the radius. So we already have the center. This is the point HK. So we find our H is -6, the K is 3. But we need the radius. So how do we find the radius? We find this from the diameter. We just use the equation that the radius equals the diameter divided by 2. And the diameter is 4, so this is equal to 4/2, which is 2. And we're going to call the radius r. So we have r is 2, and to find r squared, we just square both. So r squared is a 2 squared, which is 4. So we have the values for the center, hk, and we have r squared is 4. So now we can just plug these numbers into this here. X minus h squared plus y minus k squared is r squared. So we get x minus h is x minus -6. Minus minus is a plus, so we get x plus 6. So we have x plus 6 squared. Then plus a y minus k squared. K is 3, so this is a y minus 3. And this is equal to r squared, which is 4. So our equation becomes x plus 6 squared plus y minus 3 squared equals 4. And this solves problem number 4. Now I'm going to move on to the additional problems I chose. These are the practice problems. Problem number 1, I won't go over the answer. This is your attendance problem. And the directions are to find the distance between 2 points, 2 minus 1 to -1, and 8 minus 9. So for this problem, all you need to do is apply the distance formula. And the distance formula was given in the first problem. So you're going to use this formula here. The 2 problems I will do, though, I picked here. Problem number 2, which I'd like you to try first before you watch my solution, is to find the equation of a circle with center -3, 4, and it passes through the point 2, 2. And the problem number 3, which I've also picked and I'd like you to try, is to find the midpoint of -4, 3 and 1 minus 3. So once you've tried these problems, you can either quit the video or just watch my solution and double check that you have the right answer. So let's go through problem 2 first. So for this problem, we're going to go back and use this equation of a circle. So we need the center, hk, and we need the radius, r. So we are given the center, so we know this hk, so the h is -3, and the k is a 4. But we need to know the radius. So like the previous problem we have done, to find the radius, we just find the distance from the center to this point, 2, 2. So we are going to apply the distance formula. So the hk you can think of, for example, it can be the x1, y1, or the x2, y2. It actually doesn't matter. So we can also think of these as the x1, y1. And the x2, y2 we can think of as the 2, 2. So these are the x2, y2. So I'm just going to apply the distance formula on these 2 points, with hk playing the role of x1, y1. So we get r is the square root of x2 minus x1 squared. That becomes a 2 minus a -3 squared. Minus a -3 is plus a 3, so 2 plus 3 squared. Plus y2 minus y1 squared. K plays the role of y1, so this becomes a 2 minus 4 squared. And now we just simplify. So we take this to the square root. 2 plus 3 is 5, so that's a 5 squared. 2 minus 4 is a -2, so this is a -2 squared. And we can continue. 5 squared is 25, so we get the square root of 25. 2 squared is a 4, so it's plus 4. And finally, 25 plus 4 is 29, so we get this is the square root of 29. And for our equation, we actually need r squared, so we can just square this. Squaring the square root gets rid of the square root, and we're just left with 29. So we have r squared is 29. Now, double checking our formula one more time. We're just going to plug our numbers into here. X minus h squared plus y minus k squared is r squared. So we have x minus h squared becomes x minus minus 3 squared, which is x plus 3 squared. Then y minus k squared becomes y minus 4 squared. And this is equal to r squared, which is 29. So we have x plus 3 squared plus y minus 4 squared equals 29. Okay, let's look at the third problem here. The directions are to find the midpoint of a minus 4, 3 and 1 minus 3. So hopefully you have tried this problem first. And recall we're going to use the midpoint formula. And remember what the midpoint formula says is we have this value m is called the midpoint. And the left coordinate is going to be the sum of these left coordinates divided by 2. So it's going to be a minus 4 plus 1 over 2. And this right coordinate is going to be the sum of the right coordinates. So that's 3 plus a minus 3 over 2. Right. So let's do that. So we get 3 minus 3 over 2. Because 3 plus a minus 3 is a 3 minus a 3. So just simplifying as much as we can, minus 4 plus 1 is a minus 3, so we get minus 3 over 2. And the 3 minus 3 is a 0, so we get 0 over 2. 0 divided by anything that's not 0 is just 0. So we get minus 3 over 2, 0. And so this ends the examples I picked for today.